I'm back at Classic Engine Workshop today as the engine rebuild's about to start. Everything's been remachined and been repainted, so it's ready to go. So let's pop in and have a look at what's happened. Hi Roger, how you doing?
Hey,
good to see you again.
Good to see you.
Right, whereabouts is the engine?
Well,
I guess it's in the clean room ready to go.
It is.
So I guess under one of these sheets is Audrey's engine.
Sure.
But is there anything else going on here that's of particular interest?
Well, there's always stuff going on. I mean, this is an E-Type in build at the moment, so you can see that this one's just got its crankshaft and rods in.
Right, I can see it's another 4.2.
It's another 4.2, so this is what yours will look like in over the next few days worth of build on it.
Lovely, excellent.
So that's one there. This is a completed engine that's almost ready to go out to a customer.
That's very pretty.
Yeah. So this is an early car. You can see the pumpkin paint. It's a 1961 first week or two of production. This one will be.
Oh wow, this is very special.
Very special, very early car. You know, the one that people talk about in hushed tones, outside bonnet latch and flat floors and the rest of it.
So pretty.
Yeah, it's a lovely thing, isn't it? So that's what we're aiming for with all of the engines that go out. We don't give any of our engines any less special treatment than any others. So this is what we're expecting to see on your engine as well when it's completed.
Wonderful. So I guess that means that this one here is...
this indeed is the Audrey block. So, there we go.
So at the moment it's upside down on the stand.
It is upside down on the stand, so you can see the level of prep that goes into these. It's painted on the inside with a paint called Gliptal. It works very well, and you can see that extends all the way into essentially anywhere which is rough cast on the inside of the engine.
Yeah. Okay.
Now the idea of this paint is it seals any porosity or whatever in the casting.
Yeah.
And the other thing is it promotes that the engine oil run down into the sump where we want it to be picked up by the pump. So
yeah,
it's overall it's a good thing, and it's gives it a smart and clean appearance, and it allows us to fully inspect and look at the casting when we're doing it as well.
I can see there's some paint here.
Yeah, there's a couple of little bits of paint there. These were actually bare out of the factory, but they just tend to corrode very quickly. So these corners are exposed when you put the sump on. They sort of come up to about there-ish, I suppose. And this little ear sticks out, and you tend to get bits of corrosion just on these edges that look a bit messy. So we do that in advance.
And I see here we've got stampings in here with HRK.
Yeah, so HRK is your block reference.
Right.
And you'll see the same reference on the timing cover, which we can have a look at, which is here. And you'll see on there it says HRK. And also on the bearing cap. So we've got a bearing cap on there, and you can see HRK. Okay. And they're all numbered from one.
So it really does look as though someone's gone H bang, H bang, H bang, and then the same with each of the different letters.
Yeah. You can see they're hand stamped. They're not machined or anything like that. They're hand stamped in, and they're just done by eye as well. They're not lined up exactly perfectly, which is great, isn't it? It's just a little part of the human history of the thing, and nice as something that we can expose and have a look at and then preserve going forwards.
And looking through, there are some very nice, fresh-looking cylinder liners there.
Indeed. So if you remember when we first looked at this, we found that one of your liners had dropped a little, and for that reason, we decided that we were going to put stepped liners in.
Yeah.
So these liners have a step machined in the bottom, so that they.
So is that the small?
Yes,
little
that's the little step
there
in that you can see in the bottom there. When we spin this over, if you drop it back in again. I'll tip it towards the camera a little bit. You can actually see the edge where the liner has gone in as well.
Absolutely.
So of course this now has returned the bore to standard size.
Yeah.
So whatever it was originally. I mean these can go up to a +60.
Right.
We can still put liners in and bring them back to standard.
Yeah. Okay.
Even a block that appears to be on its last wear, we can still get liners.
I can see the faint machining marks where it's been.
Yep.
All
once,
decked, I think, is that what
yeah,
you call
it's called decked. That's right, absolutely. So once the liners have been pressed in, they sit a little proud, and then it's just the whole thing is machined to bring it back to a complete face, which of course will promote good gasket sealing
Yeah, I think we'd seen before that these actually for the coolant channels actually these are in pretty decent condition.
They're not bad at all. I mean, you have got a little bit of frilliness in there. We don't worry about that. It's well within the gasket lines.
Yeah.
And it's very typical of what we see on these engines. If it's worse than this, and we do sometimes get it worse than this, it can be slotted out and welded to return it to the factory.
But the gasket will kind of deal with the control of that. Keep it sealed, won't it?
I mean, typically we actually see the cylinder heads being worse than the blocks.
Oh, okay.
Generally,
so I guess these being cast iron rather than aluminium.
Sort of slightly counterintuitively, the aluminium seems to corrode worse on the cylinder heads, and we quite often have to machine out the slots, have them welded. Yeah.
And of course, nice fresh coat of black paint on the outside, and lovely fresh core plugs as well.
Paint, yes. Well, everything comes out. All of the core plugs, the gallery plugs, and everything come out of these engines before we send them to be acid dipped, and that ensures that we've cleaned out the whole cooling jacket. You do get a huge amount of corrosion and silt build up in these blocks, and I don't know whether I probably sent you a video of what happens when we pull the core plug out and you put your finger in and it's full of a sort of orangey mud.
Yeah.
Well, of course, what we tend to find is the cylinders further away from the water pump. Mm-hmm. You start to see much worse wear patterns in, for instance, the valve guides and in the cylinders as well, from the fact that the end cylinders don't get as well cooled, and therefore they're running hotter, and therefore they wear faster.
Yeah. Okay.
So that's something quite common we see is this pattern of when we measure the bores, they're getting slightly worse towards the back, and it's always because this water jacket is silted up.
Yeah. Okay.
And full of corrosion. So the acid dipping is absolutely it's absolutely required to return it to. I mean, it's just not worth doing one of these engines unless you're doing that.
It's one of the things actually I think I've seen advertised recently that Jaguar are now reselling a new cast block 3.8, 4.2, and
yes.
That's like £10,000, I think.
Something like that. I think
so this in effect is like worth that now.
Yeah, absolutely. I mean, Crossrate and Gardner do an alley block as well, and in fact a cast iron block, I believe. One of the things we see quite often is these cracking between the cylinders, particularly on the 4.2s. Well, you didn't have that on this engine.
Yeah, it looks amazing.
Really but if you do, you can put top hat liners in. Yeah. So a top hat liner is just a slightly bigger at the top. It's got a bigger diameter. You do a little counter bore and drop that into it, and effectively it closes up the two gaps. Meet in the middle, as it were, and that can repair that. And the other thing is, I mean, your block was absolutely perfect in the line bore, but sometimes if you want to flip it back over again, quite often what we find. Well, drop that back in there. Quite often what we'll find is that this, where the crank runs, is moved around or has got some ovality or whatever it might be. Yeah. And we'll re-line bore this in one piece. Take it back to factory. It just involves skimming the caps to make them oval, bolting them all on, and then line boring and honing it. To back to standard size, so that can be repaired as well. So there's not a lot that can't be done to bring these back. And actually, we've had ice damaged ones, ones where they've cracked the block, okay. And we can have those laser welders and stuff like that.
Yeah,
but, that can start to run into some serious money if they're big cracks.
Yeah, okay.
But it can all be done now, and so there's no real reason. I mean, yes, I can see why if you wanted if you were running an FIA car or something like that, where everything being on the competitive edge, then that could justify having a new block, or if you were doing something very special. But actually, preserving the originality for a road car is, these blocks they're a big old chunk, and they have survived very well in the majority of them.
Because of course,
solid thing.
When I picked the car up for my brother, he hadn't seen it. You don't know kind of what you're going to find. So it's really nice to know that this is a very sound engine.
You remember how it was when it came in, and now it just looks like a brand new fresh block.
Right, so that moves us on to cranks. So this
Indeed.
is Audrey's freshly ground crank, isn't it?
It is. It's been reground to the next size, which I think on this one was a +20 on both big ends and mains. And this crank has also been modified to give you a full 360-degree Viton lip seal, which is an upgrade on the original rope seal. Now, we talked about the rope seals, didn't we, in a previous conversation. On this one now we're using the full radial lip seal, which is Viton lip seal. So there's a modification to the housing, the rope seal housing, which allows you to put that 360 seal in. Now you'll notice that compared to a standard crank, we've now lost this flange around here, which the flywheel originally bolted to. So now we've got a smaller pitch circle diameter on the flywheel bolts. We've got a new flywheel altogether.
Yes, that's a brand new flywheel.
The
other one looked pretty tired, didn't it? It
was quite badly grooved as well, wasn't it? It was pretty bad. The original flywheel was quite worn out. I don't think we
I hold it actually.
Yeah, of course you can. Yeah. It's still a fairly sizable
quite
piece.
Chunky.
Not
ridiculous.
But it's all part of the character of the engine. It's not a high revving engine. You don't need a super light flywheel or anything like that. It's not a racer. And you want it to have good road manners and nice low idle. So we can do that. And you can see that this has a much smaller pitch circle diameter than the original flywheel. And we bolt these on with ARP hardware as well. This whole conversion comes from Rob Beer Racing.
You can see that there are various kind of marks here where it looks, is that part of the balancing process?
Yeah, absolutely. So this has been balanced with the new flywheel and the new clutch. And any hardware that goes on the front end as well, so the crank damper and so forth would have been included. And you can see here, for instance, where we've had material removed to balance it all up. So that's ready to go, essentially.
Wonderful. So this is one of the bagged up, ready to go conrods as well, isn't it?
It is indeed, yeah. You're more than welcome to open that bag, in fact. If you pass me those scissors there, we can open that. So this is a
We've stuck with the original ones, haven't we?
We've gone with the original rods. They were in great shape. Very often we end up resizing the big ends. For instance, on these they were perfect. There's no need to do that. We'll simply replace the rod bolts and nuts on these because they're a very highly stressed item in the engine. There's no point risking having one that's several decades old in there that could let go at any point. And we've had new little end bushes in here. Now you might notice that we appear to have blocked off a hole that may have been considered to be a critical.
So there's a hole that runs all the way down. Yeah.
So there's a drilling all the way up the shaft of the rod, and originally that would have taken oil pressure from the big end up into the little end bush.
Yeah.
But these days we consider it to be the priority to oil the crankshaft. So priority main oiling is the phrase that gets used quite a lot, so just keep the oil in the places where we could see a potential engine failure. And we flip the little end bush round effectively to block that off. And then I do a small modification at the top here, which is essentially just to put a little countersink in there to create a little reservoir to allow oil to go in. But fundamentally, this is just putting the...
So you use the hole that was for the down bit on the up
bit. So it's lined up at the top, so you've got the oil and it's just splash fed in the same way that the later type rods were, and in fact just about every other conrod on the market these days is done like this. Very, very rare to see this feed up here. This is much more of kind of an earlier engine design. And was found to be unnecessary, essentially.
Yeah, fair enough. Well, again, it's nice to be able to reuse the original, and it's been twist checked as well as stretched and all that.
So it's been vapor blasted to clean off any surface corrosion, and then after that, it's had its new bush put in, and it's been checked for twist and bend to make sure that it's straight, and we're not seeing any of that. I mean, if you do get twist and bend in them, you can very often see it in the wear pattern on the bearings. So when you take the bearing shells out and have a look at them, if you've got uneven wear, say highly polished on one side and possibly on the opposing side opposite there, then that's very likely to be a twisted or a bent rod. And they can be straightened. If it's only 2 or 3 thou, you can actually have them straightened. They just tweak them with a bar until they're straight again.
Right, okay.
There's no science to it.
Amazing stuff still, isn't it?
Yeah, it can take it. Obviously, if you have a very bent rod, I mean, I have seen an engine failure actually caused by bent rods, and that was where somebody had hammered a gudgeon pin out, and held it in the vise like that, and hammered the gudgeon pin out.
Oh.
You can still see the vise marks
Oh no!
where they'd done it, and they bent the rods considerably. And
Yeah.
at that point, you know, you really do start to see to see uneven wear on the pistons, and even a piston seizure, which is what we had on that.
Yeah, no mechanical sympathy.
Not a lot, no. So you know, my pro tip would be hold them very carefully in a wood or soft jawed vise.
Yeah. Okay.
When working on them, and you know, don't put any undue side forces on them or anything like that.
Okay.
When working on con rods, because they're quite sensitive. It's quite easy to bend one, actually. It's easier than it looks, considering what a big chunk of metal it is.
Okay. And when I arrived earlier, this had red grease on each of these journals here.
Sure,
so,
yeah.
These look, compared to before, chalk and cheese. These are beautiful surfaces.
So these are freshly ground to the next size, and they've also been measured and checked that they're within the tolerance for the plus 20s.
Yeah.
And then when you arrive, we put some storage grease on them to make sure that we don't get any little they corrode very quickly. It's such a beautiful, clean steel surface. It corrodes. It flashes over.
Just take any moisture from the air. And
exactly.
stuff.
Yeah. You look around and it's got sort of yellow pitting all over it, and you're like, oh. So that's how we look after them whilst we're storing them.
I have to say, I love these little nylon stands that you've got here.
They're good. Nylon V blocks. Yeah, they're very handy. They don't damage anything, and because they're white, you can see if there's any foreign bodies on them or whatever. Clean them off and make sure you're not scratching any brand new surfaces. And we use that for inspecting them. And
oh god, it weighs quite a lot, doesn't it?
It's a bit of a chunk, isn't it?
It's a lot of reciprocating mass at the bottom of the engine, isn't it?
It is. Well, that's a really good illustration of why we have them balanced.
Yeah,
because there's a lot of mass spinning around there, and you really don't want it to be off balance. You can get some pretty high forces, imbalance forces building up if there's even the slightest mass in the wrong place. So I mean, you can see it's quite a. You can see when you look at it, it's quite a long stroke crank.
Mm-hmm.
They're quite big webs.
Yeah.
There's a lot of off-center mass
mm-hmm.
there, so you really do need to be careful about making sure they're balanced, and the old balancing a coin on its edge when it's running, and so forth.
I've seen that done in the centre of the cylinder head.
Yes, well,
good sign. We'll try that later.
We can try that, and and the other thing is they idle beautifully. Because it's a big mass, because you've got a decent sized flywheel, they idle, so 600, 650 RPM, whatever it is, something like that, and with perfect smoothness and balance, and that's partially inherent to the straight six design. The architecture of the engine is inherently well balanced, and then ensuring that your individual components are well balanced as well. So we check the rods for weight, and we check the pistons for weight, and we balance the rotating stuff. And on a race engine, we end to end balance the rods, and we weight match all the pistons as well. So within a gram as well, because obviously
the next level.
Well, that's because of the higher revs, really.
Yeah,
I mean,
of course.
a standard E-Type, you're only revving it to maybe 5.5, something like that.
Yeah.
You're not thrashing the pants off it, and those acceleration forces within the pistons and the reciprocating stuff really start to build up at higher RPMs.
Yes.
So
we've talked about doing the NC 500 as a kind of when the cars run in. My brother, a flyover from Australia, will do that.
Perfect.
We're not planning on doing the Daytona 500.
No,
or anything like
that would be Let's have a talk about a different setup if you're thinking about doing that. But this is perfect for the NC 500.
Perfect, excellent. And this here, I think, in order to keep things lubricated, is an upgrade, isn't it?
Yeah, it is. This is a Rod Beer Racing high flow pump.
It's a funny little thing. There's not much to it, but basically.
It's essentially a standard. It's essentially a standard E-Type pump, but it's nicely blueprinted. I think the gears might be a little longer, and I think Rob's claim for this is something like 30% increase in flow.
Wow. Okay.
Which is particularly valuable at idle.
Yeah.
Low RPMs and whatever, a higher flow pump is really what you're looking for. From you've got less rotations to push the oil out.
Yeah.
And this is great for stop-start driving and all that kind of stuff. And of course, at the top end, a standard pump will be working hard and keeping things nice for a standard road engine. There wouldn't be any reason for it, but particularly I think for idling and cruise, low RPM cruising, this is a really great upgrade.
Excellent. Well, I mean, it's great to have the recommendation and the knowledge that it's a it's done regularly. But I can just go and grab the Sump, because of course that surrounds all of this.
It does.
This is looking absolutely lovely. Such a big lump of Sump, isn't it?
It's a chunk, isn't it? Yeah, it's unique to the E-Type.
So,
as well.
yeah, sorry, don't forget to pop that in there, yeah.
Absolutely, bring it in.
So, beautifully vapor plasted aluminium Sump with the oil pickup point in the bottom here, and it's just, you know, it's as new. So you've had this replated,
isn't it? Yeah, so this is just as the original one replated. You can see, if we pull it out, you can see the baffles within, which control the oil from sloshing from side to side and front to back.
Okay,
in it.
yeah,
So
yeah.
these little sections are designed to make sure that as you're cornering or whatever, that the oil is contained and kept where you want it to, and it doesn't all slosh up one end, because it's a bathtub basically.
Yeah, well, I guess they must do that. I mean, this is a bit like a ship.
Yeah,
it's the hull of a ship.
It's the hull of a
I guess
ship.
they probably do similar things.
You put some bulkheads in and stop the water from sloshing from one edge. Well, in this case, it's oil. But yeah, these baffles are a pretty neat and simple way of making sure that the oil stays where you want it, and you don't get any unwanted oil surge.
But this is the original part.
This is the original part. Yeah,
it's amazing. It just doesn't look like it is brand new.
Yeah, it does. Well, they're pretty well protected and sitting in the sun. So essentially, all we do is we clean them. We degrease them thoroughly, and then we send them for electroplating, and they come back looking shiny and beautiful.
That brings us along to this lovely looking cylinder head. Now, I've got to explain at this stage, this isn't the original cylinder head, is it?
It isn't.
For the engine.
No.
And so neither should it be gold, but we've decided to make it gold because
it's pretty.
It's pretty.
Yeah.
And because it's not the original cylinder head, we can get away with it. So it would have been silver, or perhaps actually raw cast, I think, for a
Indeed,
car.
yeah. I don't think they were ever painted silver. I think they were always a bare aluminium once they were done. So this is correct for an earlier Series 1 4.2. Yeah. Is this gold colour? But I think it looks lovely, nice addition, and nothing to get too heated about the idea of doing that. So I think it looks great on the head, doesn't it? Yeah. And of course the front face is polished, which would.
Yeah. So it's just this little bit in here that was done along there. So that's as how it would have been on a slightly earlier
4.2. Yeah, absolutely. So this has had quite a bit of overhaul on it. Pretty much everything's been done on it. So we've had. We can talk about the tappet guides. Yeah. So the tappet guides that run through here, where the tappets run. They wear, we get an hourglass wear on them where the tappet rocks side to side with the motion of the camshaft, and over a number of tens of thousands of miles it starts to rock more and more and more, and at some point they actually start to make a noise as well. Sometimes you're looking for a ticking valve clearance or whatever, and it turns out to be that the tappet's rocking and it's
okay. So it's a new set of
it's a brand new set. So these are oversized tappets. They're slightly bigger diameter than the original ones. Mm-hmm. These are pull tested to check that they're not loose in the head. So they do a torque test.
This part here.
Yeah. So these are press fit into the head, steel tappet guides. They're given a torque pull. So they put a tool in, wind it to a torque. As long as it doesn't move, they're considered to be good, because there is a risk of these falling out of a cylinder head.
Which we don't want.
That makes a hell of a mess, and I've seen a few of those that have come in with where one of these has come out. Usually it's associated with overheating, although in race or high performance applications I've often seen tappet tie down kits where people put some kind of bar in there, or even drill through and put a grub screw in there. There's
I think you showed me previously where you've done that yourself.
Yes, indeed. Yeah, I had an engine in that a customer had requested that on.
Yeah, okay.
When I spoke to you one time before.
But in this case, because it's a road car engine, we're not going to upgraded performance particularly. It's
and that doesn't increase the performance. It's more of a safety measure to make sure if one of these guides comes loose that it doesn't smash the place up. Mm-hmm. So what we're seeing in here is the original guides. They all passed the pull test to make sure they didn't pull out under a bit of torque. Brilliant. And they've been machined out, reamed to 1.4 inches, and then honed individually. You see this one's got E2 written on it. Okay. So that's your exhaust. This is the exhaust side of the cylinder head, and on an E-Type we count from the back. So that's from aeroplane engines. And so now we've got something which drops in and it slides up and down. You can see that how smoothly that goes in. I've got a magnet here to pull it back out again. You can see how smoothly that goes in.
Lovely.
And out.
Yeah.
And there's absolutely no rock on that. So we've got something like 1 to 2 thou clearance, which is more or less what the factory tolerance is.
Perfect.
And of course, each guide is honed to its specific tappet to make sure that we've got perfect fit.
Okay, and I see the camshaft cap. So is this new bearings in there for the?
Yes, we always put new shells in there. They are cheap.
Yeah, fair enough.
And
obviously a very
there's
simple
no
thing
reason
to do.
not to do them. And this whole head's been vapor blasted, and these have been vapor blasted. What we do actually, which is a good tip for anybody building their own, is before we put the valves and springs and tappets and everything in, we put the cams in on their own with the new bearings.
Mm-hmm.
We torque them up to spec, and we check that they turn smoothly.
Right. Okay.
Now on an E-Type, the cams are quite slim, and they can bend, and I've seen sort of 20 thou of bend or more in ones that have come out of a running engine. They're quite flexible.
Yeah.
If you put them, we looked at the nylon V blocks that I've got over there earlier. If you put them into a pair of nylon V blocks and use the heel of your hand, you can actually straighten the bend out of them. They're quite flexible. They're more flexible than they look.
Yeah, is the cam out?
We can grab a cam, yeah, sure, no problem.
Yeah.
Okay, so so we've got ourselves camshaft here, and when you use a dial indicator on here, rotate it and see how much run out you've got on it.
Yeah. Okay.
And if you need to, you can actually just put your palm of your hand on it,
Well,
give it a press on
rather
the
you
bench,
than me,
and straighten it out until you see that that's running true. I mean, they whip and flex around quite a bit. I think is
I guess they must do. Yeah.
They're a lot slimmer than many camshafts, and they're quite a long item. So I do think they suffer from that. I very often see they're bent when they come out of an engine.
Right.
So you just got to make sure that once this has been installed with just the camshaft on its own.
But you can see the bearing surface is obviously from these parts here.
Yeah, that's
it's only that much maximum between
sure,
each of the bearings.
that's your span that we're coping with. So you've only got 2 lobes between each pair of journals.
And you said that this cam was in, both cams are in good condition.
Absolutely perfect. They've just been cleaned. They're drilled so that you can you can clean them out all the way through, and they've got the oil feed here. So we put these through our high pressure lance wash, make sure everything's coming out cleanly, and then we put an endoscope down them.
Oh, okay.
So we've got a little endoscope camera with a little screen, standalone screen. You just stick it down, have a look, make sure that there's nothing inside there, and then they're good to go. And very often they're clean to reuse. Really, the biggest enemy of cams in E-Type seems to be corrosion.
Right.
When they've been stored badly or whatever, you quite often get pitted and corroded journals and lobes. But again, we can have those reground as well, as long as it's not serious.
Yeah.
And of course, if needed, we can buy brand new cams as well.
Yeah, of course. I can imagine they're relatively
available. Easily available. You can get billet ones with any profiles you want on and all sorts of stuff. So there's no shortage of options when it comes to E-Type cams. But the standard ones for a standard road car, good balance.
So turn the head upside down now,
Indeed.
in order to look at the combustion chamber and the valve. So you've got some new valves here and the old valves.
The original valves, yeah.
And these are stem seals?
Stem seals as well, yeah. So we've just going to have a look at some of the additional modifications that we've done to this cylinder head. So the first thing we've done is we've put hardened valve seats in for all of the valves, inlets and exhausts.
So that means it's fully unleaded ready?
It is fully unleaded ready, and these are a very durable material, and they've been cut smoothly 3 angles as well, which improves the flow somewhat.
Mm-hmm.
And that pairs up with these valves. So if you compare the original, both in terms of holding them in your hand, you can feel this is a lighter valve, puts less stress on the valve train, and it's more of a penny on a stick design. It's quite a flat design, and it's got a little wasted stem here, which reduces the cross-sectional area of the valve stem that's presented to the airflow as the inlet charge is coming in to the chamber.
Okay, so these are inlet valves.
These are inlet valves, and you can see that this is a standard, like the original valve, and it's a bit of a chunkier thing. This one, although they are the same size diameter wise.
Yeah.
This one is a much lighter valve. Moves up and down much more easily, and also promotes this additional flow coming in, particularly at lower lifts. We're seeing a real advantage from this design of valve. And then with the exhaust valves, they're more or less a standard replacement valve in there, but it's interesting to note the tulip shape on the valve, which allows the outgoing charge to flow away more easily.
And so these, so this one here is a standard valve stem?
Yeah, that's absolutely right. So the original E-Type valve stem seals, all XK engine stem seals, they only go onto the inlet valves because the material would harden and crack if you put it onto the hotter exhaust guides. But also they're a pretty poor design. They don't do a lot. They do fall off and they're just all a bit rubbish, really.
Okay.
So what we do is we move to a modern steel jacketed Viton stem seal. It's got a little metal spring that keeps it nicely sealed around the valve stem, and inside here it's ribbed so that it doesn't pop off the guide. And we do a relatively small modification to the top of the guide to accommodate this, and we fit these to all 12 valves, so your exhausts get stem seals as well.
It can cope with the temperatures.
These can. This is a modern guide. This is the kind of guide you'd see on a modern engine.
You mentioned about the three-way valve seating.
Yeah, so the
was that not standard?
No, it was standard. It was a 45-degree valve seat cut. The three-angle seat is something you'll hear spoken about quite a bit. Essentially, it promotes the flow through. You normally have something like a 30-degree upward cut, 45 where the seat is, and then an open cut like a 60 that comes into the chamber. There are, in fact, continuous cuts now as well that some people are doing, where you've got a completely smooth transition with a multi-angle, or in fact completely smooth cut through there with a small 45, and that really promotes the flow in as well. But a three-angle, does 99% of that work. And if you have a look at these chambers as well, you'll see that the new seats have been blended into the ports, and the new and also blended into the chambers around the edge of them. So you've got this completely smooth transition from the port through the curtain between the valve and the seat and into the chamber. So it's a vast improvement over the standard. So these will perform a little bit better than the original.
The original inlet manifold has now been polished up.
Perfect.
And the polished cam covers for engine reassembly.
So these you've done yourself?
Well, I've had some help with these.
Okay.
So I fortunately we got some professional polishing help. The guy that's done all of the chrome plating on the car, Alan Olner, has very kindly invited me over to his workshop. So there's an episode I've done on the polishing of these aluminium parts, and it's very nice to be able to return this. Of course, these aren't the ones that were originally fitted to this head, were they?
No, indeed. Yeah, well, I think this was from a later engine originally, wasn't it? This cylinder head, so it had the ribbed cam covers. Yeah.
So with these on, I think obviously with the gold painted head, it'll look the part. But
Absolutely.
Roger, thank you very much.
Look, a real
for
pleasure.
letting me come over again, and really looking forward to seeing the completed engine, and then I'll have the task of getting the car ready
coming soon
to match it. Well, I hope so.
It's exciting though, isn't it? It's really pressing on.
One day we'll take it out for a drive.
Yeah, amazing. Look forward to it.
Cheers.